In this video, I'm going to be refreshing your mind on conversion factors from Intro to Chemistry. So let's start with the basics. What is a conversion factor? Well, what a conversion factor is it's a way to cleverly multiply by 1 so that way you end up with different units than you started with. So what do I mean by that? Let's start with a very common conversion factor. One that you would be able to find in any conversion table. We have 2.54 centimeters is equal to 1 inch. What this means is that these are the exact same quantity. Right? So, if you divide one by the other, you're going to end up with 1. If they're the same thing and you divide the same thing into itself, that means you get 1. Now, how is this useful? Well, let's go through an example, and hopefully that'll make things clear how it's useful. Let's say that someone asks you how tall you are, and you tell them you're 6 feet tall. But maybe they're from a different country or something, and they're like, what is that in meters, though? Well, so we want our final answer to be expressed in meters. Okay, so what we want to do here, we want to start with what we're given. We want to start with the 6 feet. And we're going to multiply this by conversion factors to get from feet to meters. Now, because you're multiplying by 1, you're not changing it. So we're going to end up with the same quantity, just a different number with different units. That's the beauty of conversion factors. So let's get through this problem. We have 6 feet. Now, we can't just jump straight from feet to meters. You could if you Googled a conversion factor online for feet to meters, but you're probably not going to be able to Google on the test, and most of the times what they do is they give you common conversion factors. Now, if you have your chemistry textbook, there should be a conversion factors table somewhere in it. In the case of mine, it's in the very back. So I'm only going to use conversion factors from my book. And that's what I would recommend you do to get used to how you do it on the test. So they don't have one from feet to meters, but they do have one from centimeters to inches, and almost any conversion table should have that one. Well, I don't have centimeters and inches here, but what I do have is feet. If I change feet into inches, though, then I'll be able to get from inches to centimeters, and then from centimeters to meters. So that's the sort of thought process you want to have. So how do we change from feet to inches? Another conversion factor in your book, most likely. 1 foot is equal to 12 inches. Okay, pretty simple. So we're just going to multiply by that. And the way we want to set it up is so that we have feet on the top here and feet on the bottom here. That way they cancel out and we're left with inches. We want to do the same thing with inches here. Right? So you always have 2 ways to set up a conversion factor. Now I want to cancel out those inches so I get centimeters. So I'm going to need to put the inches on the bottom. Right? 1 inch is equal to 2.54 centimeters. Now, one last, and this one's going to be the easiest to remember most likely. Centa, the way the metric system is set up, is that centimeters just means 100 of them. So 100 centimeters is equal to 1 meter. Now you see the inches cancel as well, and the centimeters cancel as well. So we're left with the only units of meters. Perfect. So if we plug this in our calculator, we'll end up with, including significant figures, 3 significant figures, we'll end up with 1.83 meters. And then that there would be our final answer. So if a friend from another country asks you what your height is and they want to know it in meters, you know that 6 feet is equal to 1.83 meters. So that is how you'd solve the average conversion problem. Now I want to go over a very important rule that you need to remember when working with conversion factors. Now, if you square or cube the units, you're going to have to square or cube the conversion factor as a whole. So what I mean by that is, here we know that 1 meter is equal to 100 centimeters, just because of the way the metric system is set up. So if we want to change from meters to cubic, if we want to change from cubic meters to cubic centimeters, what you have to do is you're going to have to cube everything, not just the units. You also have to cube the numbers. Now it doesn't really matter if you cube the 1, of course, because 1 times itself 3 times is still 1. But that's just there to emphasize that you cube everything. Everything is cubed. So let's work on another problem to emphasize how important this is that you cube it. Let's say that you have a 13 cubic meter box, and you want to know how many centimeters that is. Well, remember, we know that 1 meter is 100 centimeters, but this is meters cubed, and meters cubed don't cancel, at least not completely. So what we're going to have to do is we're going to have to cube this whole thing. So we cube the whole thing. You see the meters now cancel on the bottom and the top. So we end up with 13 times 100 cubed divided by 1. So that 1 isn't changing anything. Now, what does that give you? That's going to give you 1.3 times 10 to the 7th centimeters cubed. Now I want you to realize how big of a difference this would make as opposed to just multiplying by 100. Right? 1.3 times 10 to the 7 means you move that decimal place back 7 places. So you're going to have 6 zeros, then 13. That's a big number. If you just multiplied this by 100 without the cube, that's going to be about 1,003. Yeah, that's going to be 1,300. That's a lot bigger. So you got to be very careful with these because you can get answers that are far off if you're not. Now, just one last thing that I want to point out before this video ends. And it's a conceptual thing, not a math thing. So, lots of people seem to mix this up. And it's very important to remember that conversion factors are not changing the physical quantity you're representing. All they're doing is they're changing the units. Right? So in the first example, when we were talking about how tall some guy was, you have 6 feet. They're 6 feet tall. Now, I want you to realize that I was talking about the same guy when I said 1.83 meters. That's the same height, right? A 6 foot tall guy and a 1.83 meter tall guy are the same height as each other. So it's not changing the volume or the surface area or the height or the length of time that you're talking about. All it's changing is what units you're looking at that quantity in terms of. So that's really the gist of conversion factors, and I hope this video was helpful.